So back here, minimize it, full screen this. Now, I presume that text is fine. I don't need to make it any bigger or smaller. Yeah? Okay. Now, so we did Dex. Now, Dex is basically the main thing we're saying here about is Q. As well, also, there's a new thing on now. Marek did this yesterday. A lot of work put into it. On the Google Drive, okay, there's a new folder called Collections. All right. So you can see it, Collections. It's on your Google Drive. And inside it, there's two files. You need to download these two files onto your machine. You have to put them in the same folder. All right. And you click on the collection icon, comes up with a web page. All right. These are all the different types of collections. Okay. You can see the super interface collection has got a sub interface list, sub interface queue, sub interface set. Set is a sub interface called sorted set, and navigatable set, and something called tree set. Now you can see there's a lot of them there. All right. The only ones we really cover are linked lists, array decks. We do a few hash sets, and we do a hash map. Okay. There's a load of them there. All right. So now for each one of them as well, if you click on, let's say, list, it'll bring you to the link of the official Java website, Oracle Java website, and it gives you an explanation of it. All right. So it is put a lot of work into that. So you can see array deck. So it gives you all the details of array deck.
But no, is it like Oracle science piece of shit?
Piece of shit, yes, usually, but not for this. Okay, but yes, it is usually a piece of shit. I'd agree with you there. All right, but for raw explanations, it's fine. These sort of things. But if you want to find out how to do something, Oracle's a terrible website. It's just doesn't talk in plain English, and it's just rotten. Okay. Actually, believe it or not, now a fairly good website for basic stuff is. Do you remember the PHP exam we did, lads? W3 Schools. If you want to find out basic things, W3 Schools. There is an exam you could do. Don't bother doing the W3 exams. They're rubbish. But the explanations they give are clear and concise. So you want to find out about something, W3 Schools is fairly good. Okay? So that is all the lists, all the collection objects. You can see there's a lot of them. There is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, so there's 27 different groups, is the best way to describe it. Okay, and you can clearly see that collection is a separate interface to map, and collection is a super interface of lists, queues, and sets. Maps then are a totally different thing. Okay, and the main ones we do is a hash map. All right, hash map and something called a linked hash map. All right, so that's fairly good. If you want to find out quickly about a particular list, double click on any of them. It'll show what linked list. It'll show you all the implemented interfaces. It'll show its so java.lang, abstract collection, abstract list, abstract sequential list, linked list. Okay, so it shows you all of the implementing classes of it. Okay, and of course you can create your own list, you can create your own queue, you can create your own set. In actual fact, most medium to large software houses are going to have their own type of list. They're going to have their own type of queue. They're going to have their own type of set. All right. Anyway, so that is useful. So thank you, Marek, for doing that, even though he's not here. So Dex. Now, decks are a sub-interface. So decks are a sub-interface of queue. Now, a queue are based on uh, a queue of people, a queue of things. Okay, so you can add to the beginning and add to the end of a queue, but you can't add to the middle of a queue. All right, that's the simple basic rule. You can add to the end, you can add to the beginning, but you can't add to the middle of a queue. Okay, you can take from the end, you can take from the beginning, but you can't take from the middle of a queue. Is that okay? And this is all done through pushing and popping. Okay. Now, if we add, that's going to add to the end of the queue. Okay. If we push, it's going to add to the start of a queue. All right. Offer is the same as add. It adds to the end of the queue. Then when we come to removing elements from our collection, pop removes. So pop returns the object you're returning. And what's the object you're returning? So it removes the first object in your list and it returns that. So if you've got Pat, Mary, Tom, okay, Pat, Mary, Tom in our list, pop will return Pat and remove Pat from the list. Yeah? So we have Pat, Mary, Tom. If you pop that list, it'll return Pat and it'll remove him from the list or remove him from the queue. Okay? Now, if you try to pop from an empty queue, you're going to get a no such element exception, which is a runtime exception. Now, poll. Poll is the same as popping, okay, in that it returns Pat and it'll remove Pat. However, if you try to poll an empty queue, it's going to just return null, okay? Whereas popping will give you a no such element exception. So that's the difference between popping and polling, okay? They do the same thing. It's just when they're operating on an empty list, polling returns null, whereas popping returns a no such element exception, okay? So you could argue polling is better if you want. Okay? Now, you can poll last, which what that does is that returns the last item in the list, in this case Tom, and removes Tom from the queue. Okay. There's also a poll first, which, as far as I know, is the same as poll. Now, so remove. Does remove the first or the last element? And I want to quickly tell me. Does remove the first or the last element? Let me just have a look here. I think it removes the first. Yeah, it does. Okay. So remove removes the first element on the list. Okay. Now it's the same as pop in that if you try to remove from an empty queue, it's going to give us a no such element exception. Okay. Now, peek. All peek does is it'll display either. So if you just go peek, this will display the first element. Okay, so it will display Pat. Okay. Nope. You can't do that. You can't view any elements in the middle of the queue. you can't delete any elements in the middle of a queue. You can't add elements in the middle of a queue. Because all a queue is about, it's about the beginning and the end of the queue. That's what a queue is about. It doesn't give a shit what's happening in the middle. All right. So if you have any sort of system where you're only worried about what's coming in and what's going out, a queue is what you'd use. All right. You don't care what's happening in the middle. All right. So you only care about what's coming in and what's going out. That's all a queue is for. It doesn't concern, for instance, here we only care about Pat and Tom. Don't care about Mary. In actual fact, Q can't do anything with Mary. All right. So peak, that will just return Pat. Now it doesn't delete it. So that's the difference between poll, pop, and peak. Peak just views it, nothing else. Okay. So you can peak the last one. You can peak the first one. So that'll just return Pat. It'll just return Tom, but it doesn't delete them from the queue. Everyone with me so far? Yeah. Okay. And then I went into about creating queues, sets, and lists from other lists, queues, and sets. Okay. Simple rule is you can create any one of those. So you can create a queue of any type from a list of any type, from a set of any type, and a queue of any type. All right. In actual fact, the way it goes is you can create a queue from any object that implements the collection interface. You can create a set from any object that implements the collection interface. You can create a list from any object that implements the collection interface. There's a number of ways of doing that. Okay. One way is when you're creating your queue, in this case here, you put it in the constructor. There is a constructor in the queue class, in the set class, in the list class that takes any collection object. Okay, so array deck integer deck numbers is equal to new array deck numbers. Numbers is a list of integers. Okay, but that what you have in there, it could be a list, it could be a queue, it could be a set. All right, so it can be any object that implements the collection interface. That's one way of creating a queue in this case from an existing collection object. The other way of doing it is, so here we create something called hash set from our list. Okay, here we create a tree set from our list. Now, the first set we're seeing, a set doesn't allow duplicates. Okay, so if I create a set from a list that contains duplicates, we can see here there's a 20 and there's a 20. Okay, this set numbers here is not going to have the second 20. Okay, so as you can see, it's very easy to convert from one collection type to another collection type. You just create a new one and you just put it in the constructor. All right. No, no, because it's an object. Okay, it's a wrapper object. And even if it was doubles, you couldn't have a number like 2 in it. It would have to be 2.0. Okay, so if I put a list that contains duplicates into a set, what happens is that the set will not contain duplicates. So you'll have 20, 4, 5, 6, 3, 4, 2,456, 123. The second 20 won't be there. 99, 100, and 3,456,789. Okay. And then down here further, I created something called a tree set. Now, this is a set, but it's a set that orders your numbers in a set order, in ascending order. So this removes duplicates and it will display all your numbers in ascending order. So it'll be 20, actually I have it down here, 20, 99, 100, 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 3, 4, 5, 6, 7, 8. Okay, so it's easy to convert between different collection types. All right, now what we said then yesterday. Now what this does here, just an example. So deck numbers, it's a queue of numbers. Okay, sum is equal to sum plus deck numbers dot pool. What that does is that it keeps taking. So let's say we have a list that contains 10 20, 100. Okay, and this is deck numbers. All right, now while deck numbers is empty returns true when our queue of numbers is empty. Okay, so while it's not empty, so it's going to keep on going while it's not empty. So sum, we've already set sum is equal to 0 up here. Then so sum is equal to sum plus deck numbers that poll. Now that poll, what it does is it gets the first number. Okay, so it's going to be sum plus 10, and then it deletes it from deck numbers. So sum is equal to sum plus 10. That's not plus 10, so sum is now 10. It does the next one. Sum is equal to, so it's going to be sum plus 10. Next one is 10 plus 20 becomes 30. Removes it from the list, removes it from the queue. The next one is going to be sum is equal to 30 plus 100. Okay, so then we end up with an empty queue. Okay, so imagine a queue, you're removing things from it. All right, as you're removing things from it, so let's say you have got 100 cans of beans. All right, and they're each priced at 50 cents. What's the symbol for cent? Is that it, isn't it? Is it C with a stroke through it? Just to see. Oh yeah. Okay. So it's 50 cents. All right. So someone buys 5 cans of beans. So we have a queue of cans of beans. And you poll it. Okay. You poll it. So then you have 95 cans of beans left. All right. Now we've done a calculation already to see how much sales we have of cans of beans today. It's 5 multiplied by 50, which will give us a total of 250. So if we've sold 5 cans of beans, we can see that there's 250 in sales. Okay, that can be all done through polling. That's what you'd use them for. Stock coming in, stock going out. That's polling. You don't care about the stuff that's in stock. You only care about the stuff that's come into your stock room and leaving your stock room. Yes? That's what a queue is all about. It's what coming in and going out. You don't care what's already there. That's what you use queues for. Now, I just briefly covered this then yesterday. So when you use any of these methods, so we create a queue, a list, a set from an existing set. So it's a different list, it's a different queue. Okay? So what I did here was I created a list of dogs, a list of dogs. Okay? And it's made up of new dog, Spot, Rex, Lassie. okay? And I called it dog list. And then I went kennel.addall dog list. So then I printed off our list of dogs, and then I printed off our queue of dogs. Okay, so I should have put this there. This is list of dogs. This is queue of dogs, or array deck of dogs. Okay. Now, it doesn't matter. So down here, I created a new queue of dogs using the dog list. Okay. Up here, I added all of the dogs in the dog list to the kennel. Okay. Now, so there are two different. So this is a queue. This is a list. So they're two different objects. Okay. They're two different collection objects. All right. However, we look at the last dog in the queue. Okay. So what is this? Last dog in queue. Last dog in list. And we can see it's the same dog. Okay. Now, it's not alone the same. It's not a copy of the dog. It is the same dog. So when you create a collection object based on another collection object, okay, you could have, let's, for instance, you could have a queue of dogs. All right. So I create a list of dogs and I call it dog list. Okay. From that, I create a queue of dogs. I create a set of dogs. I create another list of dogs. I create something called a tree set of dogs. I create something called a hash set of dogs. Okay. Now, they're all different lists. So we'll say this contains 4 dogs. All right. Now, if you create a queue from this dog list, it's using the same 4 dogs. If you create a set from this dog list, it's using the same 4 dogs. If you create another list from this list of dogs, it's using the same 4 dogs. If you create a tree set from this list of dogs, it's using the same 4 dogs. They're different collections of dogs, but they're using just the same 4 dogs. All right. So there is one. Well, a new queue is being created, but it's the same dogs. So yes, there is an object created called a queue, but that's just a different way of looking at the 4 dogs. That's all it is. So set, it's a different way of looking at the 4 dogs. This list could be a different way of looking at the 4. For instance, a tree set. A tree set doesn't allow duplicates. All right. Now, depending how you set up your equals and your hash code method, that's what determines if something is a duplicate or not. All right. If you don't override your equals and your hash code, duplicates are the same dog only. Hash set and tree set also will only allow objects that implement something called a comparable interface. Sorry, Chris, what, Andrew? No, just doesn't put it in. Oh, no, because that's only affecting the queue. Now, if you change, so let's say you got your 4 dogs and they're called Spot, Lassie, Rex, and Benji. Now, if you change the name of one of the dogs, then it's changed everywhere. Okay. If I pop a dog from the queue, pop a dog, that sounds like putting them out, putting them down. Okay. So if you pop a dog from the queue, it doesn't affect the dog list because all this queue is, this is just a queue based on backline. Okay. At that point in time. Now, if you come along and you delete something from the dog list after you create the queue, well, that's a different thing. Okay. Um, it won't affect the queue. Yeah. Yeah. It does the same thing. Yeah. It's just the same thing. Okay. It effectively does the same thing. Okay. You still have the 4 dogs. Now, if you have your equals in your hash code method, which we'll be showing you today when it comes to the set, all right? And let's say you determine in your equals in your hash code method if 2 dogs have the same weight, all right? So we'll say Spot has a weight of 2, Lassie has a weight of 1, now Rex has a weight of 2, Benji has a weight of 3. Now, if we have it set up in our hash code and our equals method, and we say if 2 dogs have the same weight, well then the equals returns true, right? If we have that set up that way, now the way hash sets operate is, the way sets operate is they'll check the equals and the hash code method of the dog class, and it'll see that Rex and Spot have the same weight, and it'll only insert Spot, Lassie, and Benji. Now that depends on the equals method. We'll say if we are going to be doing, for instance, rats. We're going to have a rat class. The rat class is going to have an equals method and a hash code method that only operates on the weight or the age of the rat. So 2 rats with the same name will not be entered into a hash set. They'll be entered into a queue, they'll be entered into a list, but they will not be entered into a set or a hash set. Okay? So, but they're still the same dogs. Now, if any of these lists, any of these collection objects, if they change something about the dog, they're changed everywhere. So they're just different collection objects looking at the same 4 dogs. Okay, we covered that in Java 1. So it's the exact same with different collection objects. Anything that implements the collection interface, if you create a list based on any of those, it's the same 4 dogs. Okay? If you change anything to do with any of those dogs in any one of those objects, they're changed everywhere. It's just all these lists are, all these collection objects are, they're different ways of looking at groups of dogs. Okay? If you have a queue of dogs, it's only concerned with the first dog and the last dog. If you have a set of dogs, the main consideration is that it doesn't allow duplicates. Yeah, it doesn't allow duplicates. That's the main thing concerning with the set. With a list, it's an unordered list that can put in duplicates, can put in null, whatever you want. 3 sets. 3 sets doesn't allow duplicates, and also it orders them. All right? It's still the same 4 dogs, but it's just a different way of looking at them. That's all these are. Any questions on that? All right? So you can have the one list of dogs, and if you want to order them, let's say by age, you put them into a 3 set. Let's say you just want to remove duplicates, you'd put them into a hash set. Let's say you want to have them some sort of queue going on. So the first dog on the list, something happens to them. The last dog on the list, something happens to them. You put them in a queue. Okay, so that's all collections are. They're just a different way of looking at collections of objects. Now, tree maps or hash maps are different things. Any questions on that? Nope. Okay. So we can see here kennel.peaklast equals doglist.get3. So we've already seen that they've got the same name and the same age. It's more than that, they're the same dog. This is a queue of dogs. This is a list of dogs, but they're referring to the same dog. So put it in here. This is comparing the last dog in our kennel queue to the last dog in our list of dogs. We can see that they are the same dog. Okay. So these are what are called shallow copies. You do need these as a shallow copy. It's copying the reference. Okay, so it refers to this list of dog. Okay, they're not the same collection object, but it's the same dogs within those collection objects. Any questions on that? So if any of these collections objects change the age of the dog, it's changed everywhere. Okay. Now there is ways around that as well. You can make the collection object immutable if you don't want any of them to be changed. You'd also have to make the dog class then immutable as well. Now I will come back to, so shallow copying. That means it only copies the reference. That means basically that kennel 2 here contains the same dogs as dog list. Now, if you want to do something called deep copying, what's deep copying? Deep copying, if we have two dogs. So, sorry if I have a dog. His name is Lassie and has an age of 2. What a deep copy is, it creates another dog that's got a name of Lassie and an age of 2. So that's what a deep copy is. All right. Now, there isn't really a method in Java that does that for you. You can use clone. Clone is a kind of a pseudo way of creating a deep copy. But there's so many, for a start anyway, you've got to determine what makes two objects the same. Do you want all your objects to be unique? So that means each dog would have an ID. Are you going to say two dogs with two different IDs are going to be the same? If they have the same name and the same age, are you going to say it's equal even though they have different IDs? You could have an equals method that acts only on the name and the age. It doesn't act on the ID. We'll do a bit more about this when we come to the next section. We'll do about cloning. Now, so I'm going to go on to the next type we're going to do. Now, the next type we're going to do is a linked list. So, static void pt6. Now, if it disappears at any stage, by the way, tell me, because that just means I have to do another one again. So this is ex6. And what is this? This is linked list. And I'll just put up this thing here. Or you can consult the collections. You can consult the collections thing I have there on Google Drive. Okay, so linked list. So what does linked list do? So linked list does the following. It implements collection, queue, deck, and list. Okay, so a linked list implements both queue and list. That's the best way to describe it for this one. Okay, that's the main points of it. It implements both queue and list. So it's kind of a halfway house between both of them. So what are the details of it? It's got collection base class, queue superclass, sorry, queue extends collection, deck extends, it's not a collection base class either, it's collection base interface. Queue extends collection, deck extends queue, and also implements list. Now, so the important thing about linked list is linked list implements both the queue, deck, and list interface. So it has the best and the worst of both worlds. Okay, so you can. Yeah, I even stopped breathing there. Listen for it. Okay, linked list implements the queue, deck, and the list interface. So all methods of list and deck are then available to this class. So allows
Terranoon, please contact extension. Terranoon to extension.
He was getting the giggles. Okay, so all methods of list and deck are then available to this class.
Terranoon to reception. Thank you.
Okay, so all methods of list and deck are then available to this class. So this allows duplicates and null elements, and elements can be added anywhere in a linked list. Check one thing here. Just give me a second. Now, so with an ordinary queue, you can't add null. Okay, this guy does allow null. All right, you also all the methods of the queue class are also available. So you can push, pop, pull, whatever. You can also add a particular element. All right, so I'm going to create a linked list of strings. There's nothing new in linked lists. I'll just do a few examples of them. Linked list, string, str linked is equal to new linked list. So I will import, and I'm going to str linked.add apple. I'm going to add another one and add a banana. So I can also go str linked dot offer. So where's that added to? That's added to the end. And then I can str linked dot push pineapple. This is added to the start. And then we can str link dot add. I'm going to add it at position 1. Come in. Hi, Carmen. How are you doing? Yeah, Carmen. No. Yeah, I have. I All right. So, huh? No. JP is not in today. Just have to run next door to them. I can't send the record. Wait a minute, Alex. Okay. So we can add at a particular position. 1, a mango. Okay. So we can use set as well. Set is part, so this is added at position 1. We can use set. This is part of the list interface. So I'm going to change, so position 2, which will be, I don't know what it'll be. It'll now be pineapple. Okay, so I'll print off the list and see what it looks like at the end of that. Okay, so I go to, is that still recording, is it? Is it still showing on the screen? Is it? Geez, yeah, because it's going for the last hour. That's fine. I don't know why. It says 40 minutes is all you're allowed for, so well, I'll keep on going. So pineapple, mango, banana, orange. Okay. So Now, you can get a particular item on the list by using the get, which is part of list. So get is from list interface. So we can go, if I want to get the first item, if I want to get at index position 1, which is mango, I go str linked dot get I got this right. Yeah, dot get 1. That should get us mango. Yes, it does. You can remove, you can push, you can add null. You can't add null, remember, on a queue. Okay. So str linked dot push null. Now here's a question. Why do you think they don't allow null in the queue? Why don't they allow null in the queue? Yeah. Well, that's one way. There's our queue. Right? We're only concerned about the last and the first. So they have to be something. They can't be a null reference. All right? So we're concerning about the first person in the queue. We're concerned about the last person in the queue. We don't really care about anything that's in between. So you can't have a null object occupying the first item in the queue, right? Because remember, ideally when you have a queue going on, each one of these, so the first object, right? So it's a person going into a nightclub. Each time a person goes into a nightclub, he pays in 15 euros. All right. So that means what's actually operating there in the nightclub payment system is that every person that comes in, it increments the amount of people inside the club by 1. It also increments your takings for the night by 15. All right. So you're going to have methods that are doing that. Methods can't be called on a null object. All right. So that's why it doesn't allow nulls. Also, they're linked, as you said there, Jason. But that's the main reason. Now, so a linked list does implement queue, but it also implements list. So that means you can add nulls. But the thing about a linked list, it's more a list than it is a queue. That's the best way to describe it. All right? Because one of the main benefits of a queue is you can't have null. Whereas with a linked list, you can have null. All right? So it's more of a list than a queue. That's the best way to describe it. So you can add null, can't with a queue. Do this with a queue. Okay. You can remove at a particular position, which you can't with the queue. So I'm going to remove at position 1. Okay. This is from list. Remove at position 1. Okay. Or you can go str link.remove. This will remove first item from list. So a linked list is a combination of lists and queue, but it's more of a list than a queue. All right. Personally speaking, I wouldn't use them. All right. Because it's neither a queue or a list. So personally, I'd rather use a queue than use this. All right. It's up to yourself. If you want to use them from this point forward, you can. There's nothing new in them. All right. It's all the methods of queue and deck are available to it, and all the methods of list are available. So as well as concentrating on the first and the last item in the list, you can also access the elements in the middle of the collection. Is that okay? All right. So that's linked lists. Yeah. Yeah. I think it's just a name. Well, well, it's well, for example, queues are linked to each other. All right. Queues do contain a point. Well, it's not actually a pointer because pointers don't exist in Java. It's just a name. With what? No, it's just a name. Oh, what do you mean? Are they linked? They're linked, yeah, through pointers, yeah. Yeah. What do you mean? I mean, the first one knows what comes after it, and let's say the second one knows what comes before it, and that's done through. And that pointers just knows.
I reckon that the object must be wrapped in some sort of container.
It is a container. It's a collection object.
Yeah, I reckon that's what's going on there. And that container has the head and the tail.
Yeah, it does. Yeah, but they're not pointers.
No, no, I know. But no, what I mean pointer in the sense that it's pointing to another object.
Yeah.
A reference.
Well, it's pointing to the tail of the other one.
Yeah, the head and the
So
tail.
if you have three.
That's how you can have a doubly linked list.
Yeah.
The head pointing to its own tail.
Okay, so this guy is pointing to the tail of this guy. Okay, this guy is pointing to the tail of this guy, but this guy is also pointing to the head of this guy. Okay, of this, it's just yeah, it's just you can use pushing and popping, Igor. I mean, it's not.
Well, indexing is the main benefit, right? But you can, yeah, you can target anything.
You can target that guy.
But you get the benefits of being a queue as well.
Yeah, but that's not necessarily a benefit.
Okay.
It's not necessarily a benefit to be a list and a queue.
Well, there's an extra overhead.
Yeah, but because if you have a queue, what you are concerned about is the first guy and the last guy. That's really what you're concerned about. Well, the first guy, so
That's all you can touch, isn't it?
yeah. So if you have a nightclub, you only care about the person who's coming into your nightclub, right? That person. You don't give a shit about this one. This one.
With a linked list, can care about the neighborhood.
You can, yeah. So with the linked list, as you said there, you do care about all of them. Maybe that's it, Igor. It's not like in C where you're all going about pointers. Right? It doesn't really matter the mechanics of it. A queue, you're only concerned about the first guy and the last guy. With a linked list, you can access the guys in the middle. That's the only benefit. Well, the exam question is going to be they're going to be putting in loads of pushes and pulls and all these sort of things, and they're asking which ones are allowed. You're going to have a linked list interspersed with an array deck, and you're going to have to understand which methods are allowed and which ones aren't allowed. Okay, that's what the exam question is going to be, right? Which actually is very confusing. I'm getting confused about pushing and pulling and all that sort of shit, right? And you're going to have to know which ones can be called by which collection object. Linked list can call everything from queue and list. An array deck can only call from queue. It's easy to know that now, but during the exam, yeah, yeah, it's not the same. No, no. It's just allows some of the benefits of a list to apply to a queue. That's all it is. Okay. And what's the benefits of a list in a queue? You can access the middle guys. That's it. Okay. Whereas a queue you can't. All right. Now, so the next thing we're going to do. Now I'll continue on in this one, so it'll be a large file, but what the hell. So the next one we're going to do, this is sets. So that's really all we're doing to do with queues and lists. Okay, so the next one we're going to do is sets. So static void ex7. So so ex7. So this is the set interface. Okay, so that's the main thing about the set interface. So I'll type this out. So the set interface does not allow duplicates. Yeah, just briefly. Okay, yeah. Set interface does not allow duplicates, and elements are returned in, now this is important, no particular order. So the order you put them into your set, you're not guaranteed that's the order you're going to get them back out. Okay, so if you put them in an ordinary set, okay, set, so let's say I'm going to put in this order, I put them in Lassie, Rex, Spot, Benji, and Lady. Okay, put them in, so that's the way you put them in. Can't guarantee that the last dog is going to be Lassie. You can't guarantee that the first dog is going to be Lady. You can't guarantee that Rex is going to be in this position. You can't guarantee that Spot is going to be in this position. You can't guarantee that Benji is going to be in this position. Okay? So you put in 5 dogs. Can't guarantee what order they're going to be in that set. Now, that's just the basic set. Now, there's a couple of sets we're going to be doing. We're going to be doing hash sets, which doesn't guarantee order. Okay? We're going to be doing another one called a tree set, which does guarantee order. All right. Now it doesn't guarantee you the way they were put in. It guarantees them by some metric you have inside it. So let's say you're going to order them by age, or you're going to order them alphabetically. It's the easiest one for there. So if you order them by alphabetically, they're going to display Benji first. Who's next? Lassie, Rex, Spot, Benji, Lady. Benji is going to be first. Who's going to be next? Lady. After that, who's it? Lassie. Oh yeah, it is too. And Rex, and then Spot. Now, how does it know to order by these guys? Okay, now this is with 5 dogs. It orders them by their name because we have done one of two things. we have either had the dog class implement something called the comparable interface, and it has one method inside it called compare to. Okay, and inside that we have the guts that compares the different strings, the different names. Or we create something called a comparator, which is an object you send to a method. Okay. Now, string class implements the comparable interface. Okay, so if you put strings into a tree set, they'll automatically order by alphabetical order. Okay, all of the numbered classes implement comparable interface, so they'll all be ordered in ascending order 1, 2, 3, 4, 5. Only objects that implement the comparable interface can be put into a tree set. Okay, so tree sets do guarantee the order, not the order they were entered into, but the order you set in the compare to method. Okay, hash set does not guarantee order. All right, but you see how easy it is to transfer everything in a hash set to a list. So you can be storing them in the correct order and list. You put them into a hash set just to see is there any duplicates. Hash set will remove duplicates, but you still have your list of dogs. Okay, so now of course an alternative to that is of course is you have a database that does all this for you as well. Okay, databases are used for large collections of data, and they're good at that. All right, so you could have your database taking care of all of this shit instead of we doing it in Java. This is just another option. Okay, now, so set interface does not allow duplicate elements, and elements are returned in no specific order. Okay, so it extends. As far as I know, it extends the collection interface. I just need to check it. I have it written down here. So I'm going to go to this guy here, collections, double click on collection. It brings up this lad, and we have a look at sets. Yeah, so it directly implements the collection interface. And the ones we look at then are tree set, hash set, and linked hash set. Okay, so go here. So it extends the collection interface, the classes we cover are, so first one is going to be hash set, linked hash set, and tree set. So the first one we're going to do is going to be hash set. Bollocks. Need to do that. Okay, so EX7. So examples at EX7. So we're here. So put in a comment here. So implements collection and set interface, collection super interface, set interface, extends collection. Show you that it does. Here it is. We have a set, and we can see set, hash set implements set. Now there is, if you're doing a tree set, it implements something called the sorted set and navigable set. But the first one we're going to be doing is hash set. Okay. So for a start anyway, set is an interface. So try this for a minute. Why isn't this working? So you can have a set reference to a hash set object. Yes? Okay. Now, there is a couple of methods of the hash set class that we want to be using. So we're going to have a hash set. So put in here, you can have a set reference to a hash set object. So, but I'm going to do hash set. I'm going to do a hash set of strings. I'm going to call it str hash is equal to new hash set. And so I am going to go I'm going to go str hash dot add all. So we're going to try and see what happens when we try to add two strings that are the same. So I'm going to add my name. You can add your own name. I'm going to add capitals, my name. Then I'm going to put in Mary. And I'm going to try and put in a second Mary. I'm going to put in Shelley. I'm going to try and put in a second Mary. Now, of course, that's wrong because I have to say, so copy that. You have to say arrays as list. Arrays.as list. Okay, now right. So I'm trying to add null, so it's lowercase NOEL, uppercase NOEL. Now they're two different, remember Java's case sensitive, so those two will be added. Yes? Yeah? Mary will be added. Shelley will be added. Now Mary here won't be added. Okay? Because it's the same as this Mary here. Okay? Now to prove that it isn't added, if I go syso str hash, we can see, now see about the order, Mary, Noel, Shelley. See it? So you can't count the order, so I'll put it in here. So second Mary will not be added, and the order cannot be guaranteed. Now, each time you run it, it is going to go Mary, Noel, Shelley. Okay. So it goes lowercase Mary, uppercase, lowercase Noel, uppercase Noel, Shelley. Okay. The second Mary is not added. Everyone with me so far, yeah? Yeah, different. Yep. No, no. When it's uppercase, it's a different word. Would it be ignore case? Oh no, that's yeah, that's a tree set. That's a tree set. Yeah. So we haven't done that yet. That's a tree set. Okay. Now, so hash set does not impose any particular order. All right. So it could be displayed anyway. All right. So
Because you don't know where it is. Is that the case?
that's the case. Well, what you would do is we're getting to that. Yeah, yeah. But here's the thing: there's only one Shelly in it, so all you have to do is str hash dot remove Shelly. It's not like with the list you could have a couple of Shellys. Do you get me? So if you just say remove Shelly, it doesn't even have to know its position; it just removes it. So now so every time, so add all will return true if it adds any of them. Okay, so it adds lowercase null, uppercase null. It adds first instance of Mary. It adds Shelley. It does not add the second instance of Mary. Yeah? Yes? Okay. Now, if I try to add, let's say, another node, okay, and I'm going to say strhish dot add. I'm going to try and add me again. False. Okay, so if you remember back to Java 1, when we're adding stuff to a list, we said it returned true if it was inserted, false if it wasn't. And we didn't know why. Why would it return true or false? It's because these guys, all right, a hash set. If you try to add an element that's already there, first of all, it won't add it. Second of all, it's going to return false. Okay, so null will not be added, and this will return false. No.
You wouldn't know at that stage.
Oh, you would. Well, you would because it would give you false. Because you want. Yeah, but you can have a while loop. You can have some sort of loop while. So as soon as it comes across false, it could exit. Okay. So now let's say we're adding a couple of strings. Let's say I'm going to create another list. So a list. So this is where they become really handy. List. And this is a list of strings. And this is going to be a list of names. And I'm going to put in a couple of names in here. So I'm going to add in a few names to this. Is equal to arrays.asList. And I'm going to put in Harry. I'm going to put in my name again. I'm going to put in Shelley. I'm going to put in Laura. I'm going to put in column. I'm going to try and put in me in capital. I'm going to try and put in Mary in capital. I'm going to try and put in Shelley again. All right. Now, so you can have a long list of things, and you could, all right, so I want to remove duplicates. You could do some sort of method, or you could just do manually go through them, and it's a pain in the arse, right? However, if you try to put these into a set, it'll only put in Harry. So I'm trying to put them into str hash. Okay, so I'm trying to put names into here. Okay, so Harry doesn't already exist, won't be added. Okay, Noel already exists, won't be added. Shelley already exists, won't be added. Laura doesn't already exist, so that'll be added. Column doesn't exist, that'll be added. Capital Noel doesn't exist, or does exist already, so won't be added. Mary, capital Mary already exists, or doesn't exist, it'll be added. Shelley already exists, won't be added. So it filters out the list for us. All right, to even prove that it does. I'm going to try and add this to our existing hash map. So I go strhash dot add all. Can add anything to it that implements the collection interface. Names is a list that implements the collection interface. So that should add Harry. Where am I? Laura, Colin, Mary to our list. Okay, shouldn't add Noel, shouldn't add Shelley, shouldn't add capital Noel, shouldn't add Shelley again. All right, so if I print it out, there it is. Laura, Colin, Harry, Mary, capital Mary, Noel, capital Noel, Shelley. Yes? So you can filter out stuff. You can remove duplicates with a hash set. That's what it's very useful for. Why would you want to remove duplicates? Yeah. Well, you don't want, yeah, you don't want the same thing in it twice. Yeah, or PPS number. Or you have, you know, when you go into setting up a Gmail account, all right? That's my Gmail. Now, anyone else wants to create a Gmail account. Now, there isn't another, I did a Google search. There's no one else with that name. So, yes, I am unique. I always knew it. Okay? So, but if someone else wanted to set up that account, what do you think is happening in the background there at Google? They could have a hash set. Now, they'll have a database, but they're going to pull it and put it into a hash set. All right? So, it checks. Try one simple way is you try to add that to an existing hash set. If it already exists in the hash set, you're going to have a message that says, please choose another email address. And you'll see it then as well. They'll offer you something like Noel Flattery. What year are we in now? 2019. Or it might give you an option of Noel Flattery 18. Or I've seen them do this, and they shouldn't do this, but I've seen it happen. They'll put the age at the end of it. Noel Flattery 48, which is never a good idea. All right? So they give you suggestions, things that don't already exist in the hash set. Okay?
Contact reception, canteen, contact reception. Thank you.
The turkeys are not dead. They're not dead. They're running around the place. Could someone please kill the turkeys? They are shitting all over the place. Okay. So str hash. Now, so Grant. Fine. That can. So what will this? So this will only add, not add strings that already exist in str hash. Okay. So it filters out the list for you. Yeah. So hash set doesn't care about the order. All it cares about is there's no duplicates in it. Okay. Now you can add null to it. All right. So let's go. So I'm going to say adding null. Doesn't care. Yeah. Yeah. It doesn't care about the order. But that's not what you're concerned about really. There. All you're concerned is, does this exist in the list? Now, so adding null, we can go str hash dot add null. So you can add null to it. All right. So you can add null. But there is a there is a um, there is a condition. So you can add a null, but take a guess what you can't do after that though. You can't add a second null. Because the overriding thing is you cannot add duplicates. So you can't add second null. So first null will be added. Okay, if you try to add the second null, false. Okay, so yes, you can add strings, you can add nulls, you can't add duplicates. It's not going to give you an error because it's not an error, because what hash sets are all about, it's for filtering out your list. It gets rid of duplicates. That's what you want. Now, so with strings, it's fairly easy to filter out duplicates. Okay, with integers, so if I do a hash set of integers, and I'm going to call it int hash. Okay, so hash set integer int hash is equal to new hash set integer. So I'm going to go int hash dot add all. So I'm going to try again. Arrays dot as list. I'm going to add in 234, 4, 67, 4, 99, 20, 99. Okay, I want to see what's being added. Int hash is, I put in so it says 67, 99, 4, 120, 234. Okay, it doesn't put in the second 4, it doesn't put in the second 99. Okay, so that's what we're going. Well, these are objects. Okay, you can only insert objects into a hash set. All right, now, so it's easy. So with strings and with all numbers, so integer and doubles, these are all objects. Now, what determines, for instance, how does the string class know that this guy is the same as this guy? How does it know? How does the string class know that? Yeah, but what method does it use? Exactly. Right now, it uses, right. So here we come to the usage of hash code. This is what hash code is really about. You can use the hash code in your equals method. All right. What it's really used for is for these lads. Okay. So a hash set determines if two objects are the same by using the equals method, but more importantly, the hash code. Mm-hmm. Yep. Mm-hmm. We're going to do that now. Okay. Now, so yeah, without, so it's going to take its hash code from the object class. Yep. So it's the same hash code if it's the same object. Okay. It's the hash code that determines, not the equals at all. The equals really has nothing to do with that guy. It's the hash code. Jeez, I don't know.
Is the hash code the address on the that points to the heap, or is the actual address on the heap?
You mean to say is the hash code generated on the fly? Yes. Yeah. So it is generated on the fly because it's generated depends on. Well, it depends, right? So if you're using the hash code from the object class, then that's on the stack because that doesn't depend on the variables inside it, right? That's just the address. If it has its own hash code, then that usually depends on the variables of the object, right? So is it on? It depends. It depends. It depends whether you have your own hash code or not, right? Now, so what I'm going to do is so this is EX7. I'm going to go into EX8 because this is kind of, I want to put this topic by itself. So I'm going to go static void EX8. Actually, now, just before I do that, for the end of EX7, okay? Now, so I'll put in this comment. If you are adding many elements to a hash set, you will not know how many elements will be added to your set. Now, imagine you've got a set that's got 50 items in it. You're getting another 1,000 values from a database. You know the duplicates in it somewhere. You're not going to know, you add them to a set, you're not going to know how many are added to that set. Do you understand that? Freaky Kieran, that's exactly what I was about to do. Okay, so what you need to do is, as duplicates are not added. So size here is more important for this class than previous collection classes. So what you do is you get the size of your set before you add elements to it. All right, so I create a variable called size. Okay, and it's going to be equal to, let's say, int hash dot size. Okay, so what's this? This is size before we add elements. Okay, and then I go int hash dot add all arrays dot as list. I'm going to add some of the same numbers: 4, 4, 99, 123, 999, 67, 121, 119, 121. Okay. Yeah. Yeah. So it can be all integers, just integers. Yeah. So how many of those numbers are added? Even with a list that small, you have to check it. All right. So what you now do is you go. You want to get the differential between the old size and the new size. Okay. So I'm going to go int diff is equal to int hash dot size minus size. I have to minus size. Okay, and so you go amount of items of numbers added to list is diff 4. Now go to your turkey and ham. Okay, so I will stop the share. Okay, and I will. Sorry, back them up, Catherine. Is she? Oh.